Hello guys, welcome to this channel, Tough Math. I am Napoleon A. Gaking Jr., a math teacher. If you are a math teacher, a math coach, or a math contestant, or even a math enthusiast, this channel is for you. The mathematics problems that are featured in this channel come from various national and international mathematics competition given during the past several years. And they appear here either in their original forms or in their repurposed versions. As such, they will be an excellent source of review and training materials, especially for those who intend to compete in some mathematics competitions in the future. So here we are. For this video, we will consider two problems, and problem number one is this. The figure below represents a network of roads in a certain area. If one can only move as indicated by the arrow heads, okay, so these are the arrowheads. Let me first go finish this one. These arrowheads. Okay, I think we already have a complete number of arrowheads that indicate the direction of the path from A to B. Okay, so we apply here two principles from combinatorics, which are the addition and multiplication principles. So applying the addition principle otherwise known as AP, and the multiplication principle, or MP. And using the results as labels for each juncture or intersection point. Okay, so first we consider the number of ways from point A to point X. There are three ways. Either you go up first and then go right, or you go directly or diagonally from A to X, or you go to the right and then stop at this point here and then go up. So you have three ways, and as mentioned, we will use that number 3 as label for the intersection point X. So we write 3 here. We'll use another color to easily distinguish the labels from the other features in the drawing. And then from X to Y, notice that there are how many ways? There are 5 ways. Either you go up and then go to M and then to Y, that's one way. And then you go from X, you go to M and then go to Y, that's the second way. The third way, or yes, the third path from X to Y is you go directly, diagonally. And then the fourth is from X, you go to P and then to Y. And then the fifth is from X, you go to N and then go to P and then go to Y. So there are 5 ways. So therefore, by the multiplication principle, the number of paths from A to Y must be 3 times 5, which is 15. 3 times 5, 15. So we write 15 here, here 15, and we will see later on that this agrees with our more detailed counting of the number of ways. Okay. And we also label the other parts. This one here is just 1. This one here is just 1 because there is just one way of getting from getting to that point from A. This is just 1. This is just 1. This is just 1. But this one here is, it must be 2, because either you go up from this juncture, you go up and then go right, or you just go from this to this point and then go up. So that's 2 ways. So this one here, that's also just 1. That the label of that juncture is just 1. And then the label of this juncture here, we cannot determine that one yet. We have to find the labels of the other portion. Okay, this is just 1 also. This one is 3, the point N, the label 3, because there are 3 ways of getting to N from A. Actually, we are also using the multiplication principle here, because from A to X there are 3 ways, and then from X to N there is just 1 way. So therefore 3 times 1 by the multiplication principle is 3. Now from N to this point, it's no longer 3 because we have this other path here below. So this must be labeled 4. And therefore this must be labeled 5. Okay? And therefore P must be labeled 6. This one must be 6. M must also be labeled 6. Okay? And this one must be labeled so sorry, there's a path here also. There's a path here also. So this one, this point here must be labeled 6 plus 3 plus 5. This must be 14. And this point here must be labeled 19 because you have 15 plus 14. And now we can answer, or we can now put the label to this point, the label must be 2 plus 1 plus 15. This must be 18. And therefore, the numerical label of point B is 47 plus 15 plus 19. That's 47 plus 15. That's 62. Okay? So this is 62. So we have 62 paths. Okay, sorry. I should be consistent in using the colors. So this must be blue. From point A to point B. Okay, so that's for problem number 1. Now we go to problem number 2. Simplify the expression Q, which is equal to A plus B times A squared plus B squared, and so on until the factor A to the 64 plus B to the 64. So this is very easy. You just multiply. So multiplying both sides by A minus B, we obtain on the left side we have A minus B times Q, and then on the right side we have A squared minus B squared times A squared plus B squared times A to the 4th plus B to the 4th times, and so on until the last factor A to the 64 plus B to the 64. And then A squared minus B squared times A squared plus B squared is equal to A to the 4th minus B to the 4th times A to the 4th plus B to the 4th times A to the 8th plus B to the 8th, and so on until the last factor A to the 64 plus B to the 64. And now we have A to the 8th minus B to the 8th times A to the 8th plus B to the 8th, and so on until the last factor A to the 64 plus B to the 64. Okay, so if you observe the pattern from one step to the next, then you can now conclude in general that the final expression would be A to the 128 minus B to the 128. Okay, therefore Q more simply is equal to A to the 128 minus B to the 128 over A minus B. Okay, I will use another color to highlight this one. So I will use red. Okay, so that's the simplified expression for Q. So I hope you like our discussion today, and I hope you are interested in seeing more solved problems in this channel. So if you do, then subscribe And thank you and God bless.